Hey guys, just wanted to look at some of these practice questions. This whole worksheet is a review on sections 1.1, 1.2, 1.3, and 1.4, but I wanted to hone in on the proofs. So we learned some shortcuts, side, angle, side, and side, side, side. So we're gonna look probably most likely at some of those. So we have our statement and our reason. And we're just going to start with this one. So they gave us that BC was the same as CD. So I'll color coordinate these. So BC will be this green triangle. And then we'll go purple for the one that has C and D in it. So that was a given. They also told us that AC bisects angle BCD, which is this bigger one right here. So bisects just means cuts it in half. Some people made this symbol up for it. It's not a real math symbol, but I kind of liked it, so I thought I'd share it. But it's just cutting angle BCD, which is this one right here. It connects B to C to D. And that is cut in half because of the word bisects. So that will tell us, even though it's given, it tells us a little bit about that angle 1 and 2. So it looks like angle 1 is green and angle 2 is purple. And those have to be the same because it literally said they bisect. So I would just write like definition of bisects. Showing that when it was cut in half, they really are both equal halves. So far we have this angle, angle 1 matching angle 2. They also told us this side right here matches this side. So we have a side and an angle. From our shortcuts, it's looking like side, angle, side, and I think I'm gonna go with that because we've got these two. These are both AC. So we have the purple AC and the green AC. And those are both the same because they're literally the exact same line. The name for that is called reflexive. And then we already have two sides that match in an angle. It's important that angle is in between. So that way when we're talking about like this door opening up, the angle is in between there. But we can now already say that the triangles match up. So the green one, which was ABC, and the purple one, which was ADC, those had to be the same, and we said it was because the sides, the angle in between, and then the sides. So that's all there is to that proof. We'll keep going. We'll do a couple more. Let's copy and paste this guy. Make that a little smaller. And we can start looking at these two. So we've got green and purple out. Why not? We have this one, ABC. And this one, EDC. And let's see what they gave us so far. So they said AB. So one of the sides matches ED, the other side. So that was just given to us. It's showing this one right here matches this one right here. There's a lot going on after this. So next it says C is the midpoint. So C is the midpoint of BD. And so that's just saying out of this whole thing, C is exactly in the middle. Which is helpful for us because if it's exactly in the middle, then this piece and this piece have to be the same. So the CD has to be the same as BC because they told us it was exactly in the middle. So definition of midpoint, or it's in the middle, or C is in the middle of BD, something like that. Definition of midpoint. Because if you recall, midpoint means it's like in the middle. Okay, so we got two sides so far. Now they're getting fancy with us. They said AB is perpendicular to BD, and ED is also perpendicular to BD. So we've got AB right here, and they're saying that is perpendicular to the whole bottom, which is BD. And then they also said that ED is also perpendicular to the bottom. And so those are given. I don't know why I did this before. I guess I could. I just got excited. I can put the givens first. But from those givens, what they're trying to tell us is this perpendicular means that there's a right angle in here. So this one has a right angle, and this one has a right angle. So I would say angle B is equal to 90 degrees, and so is the measure of angle D. Make those the right color. And that reason is the same. Perpendicular means that they're 90 degrees. You could literally write that all out, or you can just write definition of perpendicular. Perpendicular means that they're 90. It means it's a right angle. It means that they cross at a box, something like that. So it looks like because these are both 90, we can say that they're equal to each other. They're both 90. And I guess, I could just write they're both 90. We'll be fancy. We'll say transitive or substitution. You could literally just write they both equal 90. And now I think we have it. We have two sides that match, this one and this one. The angle in between matches, and then this side and this side. So the triangles ABC, triangle ABC matches up with EDC, the purple one. And our reason there is because we had a side, an angle in between, and then another side that matched. And that is our proof. A little bit more involved, but it still goes through and gets side angle side or side 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 at the end. So let's go ahead and do another one. Okay, another picture. Sticking with these colors. Okay, so we've got ABD, and we've got a CD. So they told us AB and AC were the same. So this one, which is AC, and this one, which is AB, those have to be the same, literally just because they gave it to us. We'll make that a little prettier. They also told us that AD bisects BC. So they're saying this line down the middle, it cuts the bottom in half. So they're basically saying it cut it right down the middle. So AD bisects BC. Since it bisects, you can say that the purple side, the BD, has to be the same as, I can't even see it anymore, DC, which is the green side. So CD. And those are the same because bisects means that they cut it literally in half. So this green piece and then the purple piece, they're exactly the same. So our reason would be like definition of bisects, or something about it cutting them in half, or they have to be equal because bisects cuts in half, something like that. And then it's looking like I have two sides. So I'm either going for a third side or this angle. Doesn't tell me anything about the angle, so I think I'm gonna go and try to show this side, AD green and AD purple, those match. So we have AD in purple and AD in green, and it's fairly obvious that they match because they're literally the exact same letters, the exact same line. So that is called reflexive property. And then I've got 3 sides that match, which is one of my shortcuts. So I can show that ABD, the purple one, is the same as or congruent to the green one, which is ACD. And we ended up going and saying all 3 sides match. And that is the end of the proof. So you kind of know on these, you're looking for something with side angle side or side side side. So those were the first couple. I'm going to keep going. I'm going to skip the middle, but I do want to jump and show you guys a couple more proofs so that you get really a lot of examples of those. So we'll do number 14 and 15. Okay, this one, we'll color them. We got our green and our purple. I'm just picking random ones. Green and purple. Okay, so this one's saying AB. Where are their lines, those sillies? AB. They should have done this. AB and BC match up. So BC is the purple one and AB is the green one, and they're telling us that those match, which is a given. So AB, I'll draw it in over here, that and this match. That's what they told us. They also said BD is a median. So that's another word, median, middle. So we'll just write it in first. BD is a median of side AC. Why are they not putting their lines on it? Lazy math textbook. So if they're saying BD is in the middle, again, they're just telling us this cuts it right in half. So we can then say, getting ahead of myself, this is a given. We can then say that the AD for the green right here has to match with the CD right here. And that's just because it literally said it was in the middle. Definition of median, or it said it was in the middle, or D is in the middle, so the parts have to equal, something like that. And then, again, I'm either thinking, okay, do these angles match, or is it something with these sides? I don't have a whole lot of info about the angles, so it's looking like they're going to have us go with BD has to match BD. And again, we've seen this one a lot, but it's reflexive. The purple BC and the green BC, they're both BC. So that is reflexive property. So we've got all 3 sides that we've shown. This one, and this one. I should use my neutral color. These 3. So we can say ABD, which is our green one, has to equal our purple one. ABC. Oh, sorry. ABD goes with CBD. Sorry about that. CBD. And the reason there was because we had all 3 sides that matched up. So all of these are pretty similar in that you're trying to show either the 3 sides match or the 2 sides and an angle in between. So one last one, just for good measure and a little practice, and we'll show that these 2. So on 15, we have the green one right here and the purple one. Okay, so they gave us a little info about bisecting. They said JM Maybe they just mean the distance. I like when they put this on here though. That's fine though. Okay, so JM, it's a lot to write, bisects KN. They also said KN bisects JM. And then they also said that JK is congruent to NM. Those are all givens. I'll color coordinate. We know that JK is green from our picture, and purple would be NM. So that's looking like they're telling us that this side is the same as this side. Then I need to kind of delve into what does bisects mean. So they said JM bisects KN, and vice versa, KN bisects JM. So they're saying these guys cut each other in half. So they're saying if you take these lines, this is the middle for both of them. So it's literally telling us that this, JL, has to match up with this one over here, LM. Because they said it bisects or cuts in half. So LM. And your reason there is not just because it looks like it. It's because it told us that it bisected, meaning it cut it in half. So I'll put definition of bisects. It also works the other way. So KL is the same as LN, and it shows that those are the same. So JM bisects KN, and KN bisects JM. So we'll say, oops, LN is the same as KL. And that would also be definition of bisects. I just wanted to show you this one because it has a couple different ways you could do it. You could do it this way and then say, oh, the triangles are the same because, so triangle JLK is the same as triangle MLN because all three sides match, and you could say side, side, side. But I just wanted you guys to see, and that would totally work. I wanted you guys to see that this one had another option. So let's say you maybe didn't get to this part right here. You didn't get that they were both bisected. And that was what? KL and LN. So let's say you didn't get this part. There we go. And you just had this. So you had two sides, and, oh, I'm sorry. Let me go back. Get an extra over here. Okay. So if we had this, let's say they just didn't tell us this part. What if they never even said anything about that? We didn't have these matching. And this was just not even in the given. We could actually still prove it. We have these two sides that match up. And we can say that this angle matches this angle. So JLK, angle JLK would have to match angle MLN, and that's just because these guys are vertical. So an old school usage, but we talked about vertical angles theorem. And then we would have two sides with an angle in between. And that would be a totally acceptable different way to solve this one. So there's more than one way you can do proofs, and I just wanted to show you a couple of them. I hope this was helpful for the proof section review. There's a bunch of other practice problems in there as well.